Okay, cool. So now that we're back from the thigh drill, most of us, we only have one person, but they asked permission, so we're good. Let's go through this one on the right using those exponent laws. How would you start this? Multiply what? Yeah. I heard a couple people say it, so we're going to take these two sets of parentheses and multiply them together so we can rearrange those things. So I'm going to put the numbers together. So you're right. We have our 2 times our 3. Is that... Okay, that's not an awful color combination. Sometimes my color combinations get hard to read, and if they're ever hard to read, please let me know. I can always change the color. And that leaves us with an x cubed times x squared. Absolutely fine. We can take our multiplications and break them out of their parentheses. We can do it the same way on the bottom with the cube thing, or we can simplify that a different way. What is your instincts? Yeah, to take our exponent law and do the 2 times the 3. And I'm not going to write with the white. That's going to be annoying. So we can do our x to the what power? 6th. That's using our power over powers. On top, it was that multiplication is commutative. So when we finish simplifying this, what's our numerator? 6 times x to the what? To the 5th over x to the 6th. Can that be simplified? Yes. I've got a bunch of x's that can cancel out. How many x's are going to cancel out? 5 of them. So we're going to be left with a final answer of 6 over x. Okay? We've worked with exponents. We've worked with exponent laws before. You learned them at the very latest in Algebra 1. Yes, sir. Yes, right over here by the Surfing Cat. Surfing Cat holds all, has extra pencils, extra pens, erasers, rulers. If there's any other supplies you need, Surfing Cat holds all. Okay, so we reviewed our exponent laws, all these guys. We're going to go through some radicals. We've got some vocab words up here. We've got our radical, our radicand, which is the guy under the radical, and is our index. And the little check mark thing is called the radical sign. Love that that got moved over into the middle of the words. That's so fun. I love when it plays games with my slideshow. So I'm going to cross out this random I, because that's not a part of it. There we go. Just doing a little fixing, because like the pictures wound up exactly over the words you're supposed to be looking at. There we go. That says is. All right. So we've got a bunch of pieces here. The guy under the radical is our radicand, and the number outside, the n, is called the index. That'll be when it's square root versus cube root versus 4th root, 5th root. There are technically names for anything other than a cube root, but we don't typically use them. You could do a quartic root or an octic root. We don't typically use those for anything over 3. We use square and cubic, but we just usually say the index as a number. There are names, but not commonly used. And our exponent laws, I'll zoom those in because I know our indexes are very small here. They're very similar, where if they have the same index, we can multiply our radicands. If they have the same index, we can split them apart into 2 separate radicals. And if they have a square, or like a root of a root, we can multiply the indices together. The plural of index is indices. I think. And we're going to practice with this just a little bit. And we're going to remember how to simplify a radical. Yes, dear. Yes, I will go back. Absolutely fine. Totally fine. We need to remember how to simplify a radical, so that's going to be our first thing that we need to do. So try and remember how to do that if you're to the point of being done writing these down. Because also remember, we don't get calculators for a semester, so we're going to need to simplify radicals without calculators. Not put them into decimal form, just simplify. Simplified radical. All right. Are we ready? Anybody need more time? Okay. Let's try this one. So, again, we're going to need to be able to simplify these without a calculator. I'm not meaning put it into decimal form, just simplified radical form. So what we're going to do is we're going to break it into factors so that we can try and find a perfect square within that number. What is a perfect square that is a factor of 28? 4. Because I can rewrite 28 as the product of 4 times 7. Totally fine. I can rewrite 28 as 4 times 7. It means the same dang thing. This makes my life easier because I know the square root of 4. What is the square root of 4? 2. So I can rewrite this chunk as just a 2. I don't know what that little wiggle is, but it's a thing. Okay, we're going to go with it. And then this 7 is stuck inside the radical, so it would be 2 square root of 7. If you need to have an extra step in there where you break it into 2 radicals, that's totally fine, but we're just kind of truck with it that way. So when we say simplify the radicals, we don't mean put it as a decimal. That is simplified radical form. So then let's look at this cube root on the right. I have a fraction inside a cube root. So we're going to use one of those radical laws to break it into pieces to make each one easier to work with. So I'm going to bring it in. And what we're going to do, it's very similar to how we did the fraction one on the last page where I took the exponent and split it apart. We're going to do the same thing. We're going to split this radical apart. So we have a fraction that has the cube root of 8. My 8 went wonky, but that's okay. Over the cube root of 27. So now it's really going to be pulling back from the details in your brain. Do we know what the cube root of 8 is off the top of our head? 2. Because 2 cubed is 8. So we're going to have 2 over, what's the cube root of 27? 3. 3 cubed is 27. So simplified here, cube root of 8/27 is 2/3. That's your answer. Okay. Questions on the radicals, the radical law things? We've worked with them before. It's been a thing. Okay. We're going to go through fraction exponents, and that's going to be as far as we get today. Tomorrow we'll talk about rationalizing the denominator. So fraction exponents, I'll zoom it in so we can see this part, because I know the letters are small. So that the top two lines, that is the math rules for when it works. So we're not using negative denominators. We're not using decimals. We're only using fractions that are made of whole numbers. We can have negative pieces, but we're not taking specifically negative denominators. And all it is when we have an exponent that has a fraction in it, the top is still a power, so the numerator is still a power. The denominator of the exponent is your index. So it takes our exponents and our roots and smashes them together into one thing. And I don't like they have all these fractions sideways here. I would really rather they wrote them as a to the m over n, so it was clearer. M is your power, n is your index. And you can break it apart into pieces that might be easier to work with in any number of ways. That's what number 3 is looking at on these rules, is it's taking them as products. Because what our example here is 4 to the power of 3/2. There's a few different ways, there's a couple of different ways we can approach this. We could either do this as 4 cubed, and we take our square root, or we can do the square root of 4 cubed. Either way is fine. One of those ways will feel less gross for your brain. Either way, we're going to get to the same answer, because it doesn't matter which order we do it in. They happen at the same time, order of operations wise. So you can either go 4 cubed and then square root, or you can do the square root of 4 and then cube it. Either way, what will we wind up with as an answer? 8. Because square root of 4 is 2. 2 cubed is 8. Or you can go and do 4 cubed, which is 64. Square root of that, also 8. So our answer here is 8. And I know this is just like really written as a chaotic cloud up here, and I'm sorry, usually I'm significantly more organized in the way I write things. So that's or. You can approach this either way. We're going to practice this a couple more times, working with these fractional exponents, because you did them in Algebra 2, but it may have either A, been a while, or B, forgotten, or C, didn't go super in-depth into them because it's been a minute. If you remember these, super awesome. I love it. These are our last 3 for today. So when we get through these 3, we'll be done for the day. Yes. All right. So let's start with the 9 to the 1/2. I'm going to rewrite this as a radical, just so that we can see it. So my index is 2, so it's going to be a square root. If it helps when you're in a fractional index, you can absolutely put your index in there. And inside my radical, I have 9 to the 1st. So what is the square root of 9 to the 1st? 3. 9 to the 1st is also just 9. Square root of 9 is 3. Second one gets a little harder. And there's, again, a couple of pathways through it that I see. We can either go 27 squared and take the cube root. That will be a big number and kind of annoying to do without a calculator. If we had calculators, no problem. but it might be annoying because we don't know a ton of really big cubes off the top of the head. So an easier way might be to come over this way and do the cube root of 27 first, and whatever that is, square that. Either way is fine. Whatever way you want to do it. Just make sure we're taking the denominator from our power, and that's your index. So, what is the cube root of 27? 3. So if we do it this way, we notice that this is now 3 squared. Which means what's our answer? 9. Going the other way, the other direction, we would need to know 27 squared, which is 729, and we would also need to know that the cube root of that is 9. So that's a little bit less likely for us to remember off the top of their head. Sometimes going the root way first is going to make it easier. Okay? Last one, I'll zoom it in so we can see it, because when it's on the green, it's a little bit harder. That is the wrong button again. Good gravy. Boop. There we go. So we can see it a little bit clearer. What are we going to do here? This is multiplication first, y'all. So multiply them together first. See if that'll make our lives easier. Like, it doesn't always have to be go straight into the exponents. Multiply it together first. Or at least rearrange things so we can see. We've got our negative 5 times 2 times a to the 3/2 times a to the 1/2. So negative 5 times 2, that's negative 10. I'll give us that one. When we are multiplying things with exponents, what do we do with the exponents? Add them. So 3/2 plus 1/2 is 4/2, which also simplifies down to be 2. And the exponents can still simplify that way. So we can just write it as a squared. 4/2, the fourth root of something that's squared, they cancel out. Okay? So just because it has fractional exponents doesn't mean you have to work with fractional exponents. Simplify first. Sometimes it makes your life easier. Okay? So you guys have about 5 minutes to the bell. I can never remember if it ends at 44 or 45. And so homework 1, 2, which is going to be due on Wednesday. The things that are highlighted in white are what we talked about today. The other things we're going to talk about tomorrow. Tomorrow's Tuesday, so we should be awesome. So say Wednesday's when there's class meetings. So I'm like trying to play around with things because we have class meetings, a whole lot of stuff happening this week. Love it. Please make sure you turn in homework 1 today. Homework 1 is due today. And I will try and make sure I get into the announcement pages and get those on there. I just didn't have them up there yet. This year. Like the numbers, yes, are on Canvas. They are it's a link. I can pull it up and show you. Courses. Oh, it's Grand Peaks is not signed in. All right. Yep, in the bin. So if you want to have access to the numbers, like the homework problem numbers, without having to keep track of that orange sheet that I gave you guys last week, which I also will have extra copies of, they'll go in the thing that's currently labeled groups, but will get relabeled here soon. It is in here, so if you go into the current module on that big red button, this very first link has all of the homework assignments for the entire chapter, okay? So we'll be at, this is homework 2, that's this one right here. Nope. This one, because it's Monday. Right here. I'm good at reading. It's really small from this angle. Okay? But they're all up here. Okay? Sorry, I keep saying okay. I'm trying not to. But I'm verbal correcting right now, and that's the thing. So, all right. So you guys have 3 more minutes.